Welcome back to the second part of 4.1 notes. We're still talking about complex numbers here, and if we look at the next example that I have for you in your notes, you'll see that we're trying to solve a degree 2 polynomial, and more than likely, because this section is dealing with complex numbers, we're probably not going to be able to factor this, and we're going to instead have to use the quadratic formula, which I wrote up at the top here in case you have forgotten what the quadratic formula is. But remember, it's a way for us to solve degree 2 polynomials when they're equal to 0. And like I was saying, more than likely our answer is going to be an answer that gets a negative number underneath the square root sign. In other words, it's going to be a complex number. So let's start to solve this by identifying what A, B, and C are. A would be 3, B would be negative 2, and C would be 5. Let's plug it into our formula. Negative 2 plus or minus the square root of negative 2 squared minus 4 times A times C, all divided by 2 times A. So simplifying this would make a 2, this would make a 6. Underneath the square root sign, we're going to have negative 2 squared minus 4 times 3 times 5, which gives me negative 56. So when I think about with 56, I know that 4 divides evenly into there, so I know that the square root of 56 is the square root of negative 1 times the square root of 4 times the square root of 14. So this is going to be an I, this is going to be a 2, and square root of 14 I can't simplify. So plugging that in over here, it would be 2 plus or minus 2i square root of 14 over 6. And again, this 6 has to get divided evenly into both of those, or has to get divided into both of those, which would result in leaving me with a 1 plus or minus 1i square roots of 14 over 3 as my final answer. Looking at our next example, we have two complex fractions that we're trying to add together, and the way that we add fractions is we make common denominators. Well, for this problem, the common denominator would be what I get when I multiply the two denominators together. So 2 plus I times 2 minus I. So I'm going to make two new fractions with 2 plus I times 2 minus I as my denominators. So you will remember that when we are trying to figure out how to make this fraction be a fraction with this new denominator, we have the 2 plus I portion of it, we don't have the 2 minus I portion of it. So you would have to take the numerator and multiply it by the 2 minus I. So this would be 2I times 2 minus I. Likewise over here, we have the 2 minus I portion, but we need the 2 plus I portion, so we'd want to multiply this numerator by the 2 plus I. So it'd be 5 times 2 plus I. So let's go ahead and do that. Multiplying the numerator, it's going to give me 4i minus 2i squared. Multiplying in this numerator, I would get 10 plus 5i. And then really, when I combine this to one fraction, I only bred it over the denominator once. So let's actually FOIL that to come up with what that answer would be. 4 minus 2i plus 2i, and then minus I squared. Right away I noticed a couple of I squareds. A negative 2i squared would be a positive 2. A negative I squared would be a positive 1. So when we go to combine our like terms, 2 plus 10 is 12. 4i plus 5i is 9i. Down here, the i's will cancel each other out, and 4 plus 1 is 5. Again, I want to write my answer in standard form, so this 5 gets divided into both of these, so it would be 12 over 5 plus 9i over 5. Again, that's my answer in standard form. So to summarize again, when we are trying to add complex fractions together, find the common denominator. Easiest method for finding the common denominator is just to multiply the two denominators together. And then you have to figure out what you have to multiply the numerator by to get the new fraction. and then go ahead and use your simplifying techniques to finish off the rest of the problem.